IITJEE.
What up, folks? Let's check out the next example of physics. So this one's about distance, acceleration, and velocity. So pay close attention. So you start from rest and you accelerate to some given final speed v0 after a total time kappa t. Your acceleration need not be constant, but assume that it's always positive or zero. So think about you can never go backwards, okay? If d is the total distance you travel, then the range of total d values is going to be what? So this is a nice problem. Let's start by drawing a VT graph, shall we? A velocity versus time graph. VT. Now, here are your conditions, your restrictions. You must start from rest, right? You have to start from rest with an initial velocity of 0. That's why I put my first velocity marker at 0, the origin. And you must accelerate to some final speed v0. Maybe that's here. Maybe you have to achieve this speed v0 after some time t, after some time kappa t. So these are our restrictions. There's a little loophole. Your acceleration need not be constant. Because if your acceleration was constant, the only way you could do this was by this path. But your acceleration need not be constant. So you don't have to go like this, making your velocity increase linearly every time step. Instead, you can be a bit clever and instead make your velocity 0 for much of the trip, but then accelerate rapidly in the last remaining quarters of the trip. So something like this, right? You can see that I still achieve the same final velocity. I still do it in a time kappa t. I still start from initial velocity, but I'm getting to that final velocity in a much faster time frame, right? You can see that I'm usually 0, and then I rocket up to my final velocity. And of course, we can make this arbitrarily close to my final time. I can be 0 velocity, 0 velocity, 0 velocity, 0 velocity, and then finally, very quickly, I can ascend to my final velocity like that, as such. Okay, well, with that being said, what are the implications of this? Well, notice that if you went at constant acceleration, the amount of distance you'd have to travel is exactly this much, right? How much is that? That's half VT. But since we're not going at constant acceleration, or we don't have to, check out that this distance, the area under the curve, we can minimize it to an arbitrarily small number so that you accelerate rapidly in the remaining quarters of your time, but for most of the trip, you're at rest. So that means the minimum amount of distance we can travel is 0. Okay, so let's cross out the answer choices that don't have 0, a minimum range of 0. So let's cross those two out. And let's see what our maximum range has to be. Well, our maximum range has to kind of be the opposite of this, the flip side of this, which is that you rapidly accelerate in the first few quarters, and then you're going at constant velocity, right? So let's play that again. Let's play the tape. You rapidly accelerate, then go constant velocity. You can make this, of course, arbitrarily close to v0. Or rapidly accelerate, and then constant velocity. Rapidly accelerate, then constant velocity. And so, of course, what's the area under the curve this time? What's this area under the curve? Well, let's check it out. This area is simply going to be basically my base, which is t, times my height, which is v0. And so the maximum distance that I can travel is v0 t. If I want to satisfy the conditions of ending at a velocity v0 in a time kappa t starting from initial rest. All right, folks, so what's our answer going to be? It's going to be this, which is choice B. Oh, whoops, not choice B, choice D. And thanks for watching this lecture of physics. We'll check you out in the next one. And
Embedded plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO, and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.